generating synthetic data. I think there are more interesting questions in four things. How you get machines to understand the physical world, and Jensen talked about this this morning in this keynote. How do you get them to have persistent memory, which not too many people talk about? And then the last two are, how do you get them to reason and plan? And there is some effort, of course, to get LLMs to reason. But in my opinion, it's a very kind of simplistic way of viewing reasoning. I think there are probably kind of more, better way of doing this. So I'm excited about things that a lot of people in this community, in the tech community, might get excited about 5 years from now. But right now it doesn't look so exciting because it's some obscure academic paper.
But if it's not an LLM that's reasoning about the physical world and having persistent memory and planning, what is it? What is the underlying model going to be?
That can reason and plan, then what you need is this predictor, which, when it observes a piece of video, it gets some idea of the state of the world, the current state of the world. And what it needs to do is being able to predict what is going to be the next state of the world, given that I might take an action that I'm imagining taking. Okay. So what you need is a predictor that, given the state of the world and an action you imagine, can predict the next state of the world. And if you have such a system, then you can plan a sequence of actions to arrive at a particular outcome. And that's the real way that all of us do planning and reasoning. We don't do it in token space. So let me take a very simple example, right? There's a lot of so-called agentic reasoning system today. And the way they work is that they generate lots and lots and lots of sequences of tokens using sort of different ways of generating different tokens stochastically. And then there is a second neural net that tries to select the best sequence out of all of the ones that are generated. It's sort of like, writing a program without select the good ones to get to human level intelligence. And you're going to have, within a few years, 2 years, I think, for some predictions, a country of geniuses in a data center, to quote someone who will remain nameless. I think it's nonsense. It's complete nonsense. I mean, sure, there are going to be a lot of applications for which, systems in the near future are going to be, PhD level, if you want. But in terms of, overall intelligence, no, we're still very far from it. I mean, when I say very far, it might happen within a decade or so. So it's not that far.
So AI has been applied in many ways that have improved the human condition, made people's lives easier. What application of AI do you see as being the most compelling, the most advantageous?
So I mean, there are obvious things, of course. I think the impact of AI, also exchange of code as well. And so that's one reason why I've been a very strong advocate of open source AI platforms, and why Meta, in part, has adopted that philosophy as well. We don't have a monopoly on good ideas. As smart as we think we are, we just don't. And the recent story about DeepSeek really shows that good ideas can come from anywhere. Now, there is a lot of really good scientists in China. One story that a lot of people should know is that if you ask yourself, what is the paper in all of science that has gathered the largest number of citations over the last 10 years? And that paper was published in 2015, exactly 10 years ago. And it was about a particular neural net architecture called ResNet, residual networks. That came out of Microsoft research in Beijing by a bunch of Chinese scientists. The lead author was Kaiming He at China. We need assistants that are extremely diverse. They need to speak all the world's languages, understand all the world's cultures, all the value systems, all the centers of interest, and they need to have different biases, political opinions, blah, blah, blah. And so we need a diversity of assistants for the same reason that we need a diverse press. Otherwise, we'll all have the same information from the same sources, and that's just not good for democracy and everything else. So we need a platform that anybody can use to build those assistants, a diverse population of assistants. And right now, that can only be done through open source platforms. I think it's going to be even more important in the future because if we want foundation models to speak all the languages in the world and everything, no single entity is going to be able to do this by itself. Who is going to collect all the data in all the languages in the world? Even a task that you've never encountered before, zero shot, right? You don't have to be trained to solve that task. You can just accomplish that task without learning anything, just on the basis of your understanding of the world and your planning abilities. That's what's missing in current systems. But if you accomplish that task multiple times, then eventually it gets compiled into what's called a policy, right? So a sort of reactive system that allows you to just accomplish that task without planning. So the first thing, this reasoning, is system 2, the sort of automatic, subconscious, reactive policy. That's system 1. LLMs can do system 1 and are trying to inching their way towards system 2. But ultimately, I think we need a different architecture for system 2.
Okay, and you think it'll be your, was it Jampa?
I think it's not going to be a generative architecture. If you want system to understand the physical world is much, much more difficult to understand than language. We think of language as kind of the epitome of future extraction, all kinds of stuff, to really sort of get most of the useful information out of a visual system.
Yeah. So what about other emerging technologies? Do you see quantum or superconducting logic or anything else on the horizon that's going to give us a great step forward in AI processing capability?
Superconducting, perhaps. I don't know enough about this to really tell. Optical has been very disappointing. I think there's been generation. I mean, I remember being totally amazed by talks about optical implementations of neural nets back in the 1980s, and they never panned out. I mean, technology is evolving, obviously, so maybe things may change. I think a lot of the cost there is like analog. You lose it in the conversion to interface with digital systems. And then for quantum, I'm extremely skeptical of quantum computing. I mean, I think the only medium-term application of quantum computing that I see is for simulating quantum systems. Like, if you want to do like quantum chemistry or something, maybe. And it was basically a failure. That project was stopped. Okay, so the alternative that we have now is a project called VJEPA, and we are getting close to version 2, where basically it's one of those joint embedding predictive architectures. So it does prediction on video, but at the representation level. And it seems to work really well. We have an example of this. The first version of this is trained on very short videos, just 16 frames, and it's trained to basically predict the representation of a full video from a version of a partially masked one. And that system apparently is able to tell you whether a particular video is physically possible or not, at least in restricted cases.
And it gives you a binary output. This is feasible, this is not, or maybe.
Well, no, it's simpler than this. You measure the prediction error that the system produces. So you take a sliding window of those 16 frames on a video, and you look at, can you predict like the next few frames? And you measure the prediction error. And when something really strange was wiped out by the GPT-style architecture, where you just train on the entire system. You basically train it as an autoencoder, but you don't need to corrupt the input because the architecture is causal. It's a recipe, right? Turned out to be incredibly successful, to scale really well. So we have to come up with a good recipe for those JEPA architectures that will scale to the same extent. That's what's missing.
Yeah. Well, we have a flashing red light ahead of us. So are there any final thoughts you'd like to leave the audience with before we adjourn?
Yeah, I mean, I want to reinforce the point I was making earlier. I think the progress of AI is going to take, and the progress towards human-level AI or advanced machine intelligence, or AGI, whatever you want to call it, is going to require contributions from everyone. It's not going to come up. It's not going to come from like a single entity somewhere that does R&D in secret. That's just not happening. It's not going to be an event. It's going to be a lot of kind of successive progress along the way.